Let's start with the basics. In TypeScript we have a new keyword called type, and let me just write some type. The basic shape of a type declaration is the type keyword, then the name of the type. There might be some generics in here. We're going to take a look at them later. And then there is the value, like what is this type? In this case, it's a string. Now, one thing to mention is the type here is a type alias. That's not actually a type. So if we write type type s equals string, that is not a new type. This, whenever we write s, TypeScript is going to substitute it for string, basically. So what types do we have? There are the basic value types, number and string. How do they work? Well, if we create a variable and give it the number type, or also our self-declared one, and we try to assign it a string here, we can see it gives us an error. And if we try to actually compile this, we also see that TypeScript will have told us that there's an error here. Type string is not assignable to number. The same applies to a string. If we write a string here, for example, it will be fine. If we try to compile this, we got no errors. That tells us this is a valid program at this point in time. Now, just the basic types are not that interesting. There are also literal types. What that means is, for example, we can write something like this as well. This means the type 5 is exactly the value 5. It's not any number, it's just 5. So if we have here a number of type 5, if we try to assign it any other number than 5, then we'll also get an error here. Type 2 is not assignable to type 5. So literal values are also types. The only valid one is the number 5. This also applies to strings. This will again yield an error. Yep. Type not hello, not assignable to hello. On the other hand, if we write hello, the error goes away and we're fine. So those are the base value types. There are a few special ones here. Any, unknown, and never. I'm going to explain them later when we're talking about object identity, type hierarchy. For now, let's just accept that they exist. Then the next class of types are sequence types, so arrays or tuples. Now, an array is written with the type and followed by the square brackets, and a tuple is written by the values inside the square brackets. What is a tuple, you might ask? So a tuple is a fixed length array, basically. So everything that has this number tuple type will be exactly of length 2 and will have number in the first position and string in the second position. So let's create a number tuple here. And if we try to assign it a empty array, it'll complain that, let me copy the error. It'll complain that type, the empty array, is not assignable to type number tuple. source has 0 elements, but target requires 2 elements. So there we see that it requires the 2 elements. And if we try to input invalid types here, it'll also complain that type number is not assignable to type string. And an array can have any number of elements. It can also have none. All it tells us is that every element that is in the array is of type number. The last class of types are the object types. There are 2 different ways an object type can be defined, once through an interface and once through a type. There are a few subtle differences. Interfaces can be extended, types can be in unions. And the notation is simply the key inside the object, and then after the column, the type of the key. So if we wanted to create an object of some type, then we'd know that its value and it needs to be a number. So if we type it like so, this is fine, but as soon as we try to put anything else in here, we'll get an error that type string is not assignable to type number. We can also replace it with the other one here. They have the same shape, so this is, for the purposes of this example, the same. Next subject to talk about is type equality, or when can you assign something of a type to something else. Let's say we make a second const b, which is of some type, some object. Remember, they had the same shape, and these 2 here have the same shape. And we can see we can assign a to b. Now this is different from another type system like Java's. In TypeScript, type equality and type hierarchy is decided by the type structure, not the actual type names, which is why they are also just aliases. Since they have the same key value association, they are the same type as far as TypeScript is concerned. Now, when is something a subtype of something else? Let's give this another property here. And we can see here we cannot, let me copy the error. It'll complain now that we cannot assign a object of type also some object to a object of some object, because some object is missing the other type here. What happens if we do it the other way around? If we create instead some object here, and we try to assign a, so this shape, to that shape. So we try to assign this shape here to that shape. We can see this is not an error, and that is because everything this object has is also present on some object. So in essence, a type is a subtype of another type if it contains at least all the properties in that type. Let's also quickly address generics. Let's say we have the same shape but different types here, and we want to have a function that accepts anything that has this value, and we don't care what specific subtype this is. Then we can create a new type and use generics for it. So we could call it, for example, a value of type t. So what we're doing here is we're declaring a generic value with a type t, subtype t, we don't know what this is, and the value will assume that type. So if we make a value of, let's say, string, then TypeScript knows now that this cannot be a number. It'll mark it as an error. And if we put in a string, it'll now accept this as a valid string. We can also put in here literals. So if we put something that isn't this literal, it'll also flag this as an error. And that's the basics of generics. Now let's talk about the last basic feature in TypeScript, and that's the union. So we can declare a union by using the pipe symbol. So for example, this would be a union. So what does this mean for us? First of all, let's call it number or string. And if we assign something and if we now try to assign to this number or string a value that is either a string or a number, everything's fine. But as soon as we try to assign it, for example, an object, we'll get an error here. Let's also look at the special types here, any, unknown, and never, and what they mean. Any basically disables TypeScript. So if we say something is any, it literally doesn't matter what it is. TypeScript will allow everything. When we say something is unknown, like so, for example, if we try to access anything from X, I need to type this as such, because otherwise TypeScript can actually figure out that it's defined. Anyway, we have casted X to unknown. This is the type hint, const X is unknown. We cannot access anything from X. We don't know what type it is. So until we determine the type of X, TypeScript will not allow us to do anything to this object. And the final value is never. So if we assign something that is never, it's always an error. We can never assign a value with a value never. That is useful when, for example, we want to declare that a function always throws an error, so it never has a return value, or that a property can never be set because something's an issue. Finally, there's also the function type. The way we define a function is just by using the arrow notation. So we write here our arguments, number, for example, and then we write here the return type of number. Alternatively, if we use the function keyword, we can do this as well, and that would be then the same way. We write our arguments here, the values here, and then after a column the return type. The functions can also be made generic by adding a type argument here. The same applies to the arrow functions, like so. And that is it for all the basic types in TypeScript. There are a few more advanced concepts. We'll discover them and discuss them as needed.